So a little intuition on the 7.3 thing. I wanted to talk to you guys just about a locus of points that it seems to be relevant to the geometry we're considering. Check this out. So we talked about circles, and we defined a circle to be the set of points they're all the same distance away from a given center point. So if you were to take like your one center point and you define a distance, say 5 feet or something, and you're like, well, I'll mark out everywhere I can find that's exactly 5 feet away from this thing. Eventually, you do get a circle, you know? And so now if I were to try and let's consider some other loci or whatever as they call it. So that's one locus of points. It would be a point, or the locus of all the points that are the same distance away from a given one. Here's another common locus of points. What if I gave you, instead of one dot, what if we gave you two of them? Maybe I'll put them in a funny position. I don't know. What if we gave you 2 dots and we said, let's define a locus of points that are they're all the same distance away from the one dot as they are from the other dot, you know? And so I guess if I try and find points that are the same distance away from the left-hand dot as they are from the right-hand dot, we'd say, well, the first most obvious one is the one that's right between the two, because it's the same amount to go to the left as it is to go to the right, you know, because it's in the middle. It's a midpoint. But then there are other dots that seem to fit this same description, like there's one up here, you know. It's the same amount of distance from the left dot as it is from the right dot, and it makes a little dunce hat if you draw the distances, you know. And then there's some dots that are like down here that do the same thing. Same from the left as it is from the right, you know. And if you start to try and draw all the dots that you can find that are the same distance from the left as they are from the right, it seems to describe this like it's just a straight line pattern, you know. A straight line pattern that actually goes perpendicular to the line between the two that you were given. Anyway, so that's weird. And if you ever chose a dot that was like curving out to the left, and then it wouldn't be the same distance between the two of them. It'd be closer to, say, the left one than the right one, or the other way around. Anyway, here's how this becomes relevant to our experience now. Another locus to consider would be now, instead of taking 2 dots, what if I were to take a dot and a line, and I were to try and figure out the set of all points that are the same distance from the dot as they are from the line. And so, once again, the most obvious point becomes the one that's right between the two of them. If I were to say, like, here's a dot, he's the same distance from the first given dot and the line because he's right between the two of them. So that's easy enough. But some of them are less obvious. It seems like, well, if I were to go, okay, so the next most obvious one would be if I were to go straight over and straight down, I could probably find a dot that goes there. And so if I go straight over the same amount as I would have to go straight down, then I have a dot that's the same distance away from our first given dot as it is from the line. And then I would be able to do the same thing on the left-hand side as well. This dot over here seems to be the same distance, or let's fix that up. This dot over here seems to be the same distance from the given first dot and the line. This is interesting. But I feel like we could get more out of it. And so, what if we were to say, okay, where else could we find some? And I'm thinking, like, maybe I could find a dot right here and right here or something. I don't know. Let's check if I'm doing this right. The same distance. It's supposed to be the same distance from the given dot. We'll call it the focus dot. They actually have a name for that. It's called the focus. And from the line, they call that directrix. Directrix. I guess got an X on the end. I don't know. Anyway, it seems like I chose a good dot. And then I think on the left-hand side, we got a similar one. Same distance from the line as it is from the focus. And then if we keep on making these dots and just checking them to see, is that string the same distance as this string? It seems to be working out. If I keep on choosing dots, it seems to be taking not at all a straight line pattern. Because if I ever start going more out and less up, you know, it seems to not be the same distance anymore. But what's weird about it is we start to see a familiar shape. That shape is indeed a parabola, which we've seen before. These are the this is the shape that we were graphing back in the y equals x squared days when we were looking at quadratics. And indeed, they are. Not only do they look similar, but they're the same thing. What we have now is we just have encountered a geometric definition for our parabola, and there are other definitions as well, some geometric. And so now I have this locus of points that are all the same distance away from the focus dot as they are from what we call the directrix line. Let's try and draw that again. Here's something interesting that you'll need to know about this in order to make use of our 7.3 lesson well. If we were to look at, say, the distance between the focus and what we call the vertex, that first dot that we found that's in between, you might remember we call that a vertex in the olden days. That's where the parabola turns around, stops going down, and starts going back up. It's a vertex dot. But, okay, so something interesting about that. If we look at the distance from, let's analyze this for a second. The distance from that vertex to the focus, it should be the same as the distance down to the directrix. And so here's something interesting. If I were to say, well, let's just say it was 3 steps down to the directrix. That means it's also 3 steps up to the vertex, to the focus. So that's interesting, I guess. But then here's something else about it. The next 2 dots that were easy to find were when we went straight over and straight down. And so if I were to go straight over and straight down, that ends up being, it's not real obvious, but if you notice, this amount that we're going down here is the same amount that we went down in the first place when we did 3 and the other 3. So if we were to take that, that means that this amount going down is actually 6 steps because it's the 3 and the other 3. And if that's 6, then this is 6 going out to the parabola itself from the focus because they match, by definition. And that means if I were to go to the left, it happens the same way. There's another 6, and then 6 steps down, of course, to match. So big play here. One thing that you're going to need to know, and this is probably the golden goose of what you'll need to know, is, okay, if there's a distance from the vertex up to the focus is, well, I think they call it the focal length or the focal diameter. I don't know what it is. Anyway, the focal length, we'll call it, if that's 3, then the distance it would take to get all the way across, going straight to the left, all the way straight to the right, seems to be 6 to the left and 6 to the right. That's 12 steps in all. 6 there, and then 6 on the other side. So that's 12 steps in all. So that diameter, or something that we'll call it, whatever we want to call this distance that goes from left to right, it does have a name, but whatever we want to call it, that seems to be 4 times as big as the distance that it took to get from the vertex to the focus in the first place. And that's something that'll be worth us knowing. And so keep that in mind, because that number, this 12, say, is going to show up because, I'll show you a little bit what that's about. Check this out. So how that shows up, just remember, it seems to be 4 times as big as the distance that we were originally looking at to get to the focus. And if that's the case, that helps us out, because these start showing up with the little y and x squared type equations like we had dealt with before in the past, Here's one of them that came to mind. Like, what if I give you this? If I was like x minus 5 squared, that way we got the x squared thing going on, equals like, let's say 12 times, let's not do x again, but like y minus 3 or something. What this would mean to me, and what would be relevant to our experience, is we know how to find new zero. So on the x part, the new zero is 1, 2, 3, 4, 5. And I think I did 6 there. 1, 2, 3, 4, 5. And then the y part, the new zero, is 1, 2, 3. So we're doing new zero on both the x and y directions. This is our vertex there. This is the vertex, so we know how to start drawing the parabola. That's the one that's actually the turning point, not the focus. It's the vertex that's actually on the parabola. But then this 12 reveals a mystery as well, because remember, the 12, that is the part that's 4 times as big as the distance between whatever, the vertex and the focus and all that, and the directrix and stuff. So what this means is, if that says 12, guys, we'll take it out to the side and we'll say, 12, I know what that means left to right wise, but also if I divide it by 4, because it's 4 times as big, divide that by 4, that means that it's 3 steps to get from that vertex up to the focus. So we'll say, okay, I'm starting to be able to draw this now. 3 steps up to get to the focus. That's 1, 2, 3 steps. I'm going to put a focus dot here at 3 steps higher. 1, 2, 3 steps higher. And then the directrix, the line part, will be the same thing, just 3 steps down, because they're the same distance away, right? And so we'll say there's our vertex, the focus, here, vertex, focus, and then the directrix will be 1, 2, 3 steps down. That's where our our directrix will start coming in. That's the line, and then the focus is the dot on the inside, and then our vertex is, of course, that's our turning point in the actual parabola. If you wanted to give it a little bit more gumption as far as like being accurate with your description, then we know that, here, let me choose a different color here. Then we know that if we go up to the focus and go straight to the left and to the right, then that total diameter or whatever distance is going to be 12 steps. So that's 6 to the left and 6 to the right. So if you wanted to be real accurate about your drawing, you go take it from the vertex and go up to, your 3 steps up. And you go 1, 2, 3, 4, 5, 6, put another dot, 1, 2, 3, 4, 5, 6, put another dot, and now we got ourselves a description of our parabola. At least a basic descriptor for how wide to draw this thing. Anyway, you may not have to go that far with it, but do remember that if you see a 12 floating around, that means we're going to divide that thing by 4, and that'll tell us everything we need to know about how far to go to get to the focus and the directrix and etc. Only other thing you'll need to know for the intuition about this stuff, guys, is wanted to mention this. You'll notice that, so classically we're dealing with y equals x squared type stuff. Just like even in the last one, the equation we had, the x part was the squared part. X minus 5 was the squared, and the y part was not. It was just y minus 3. So y equals x squared, we end up doing our up and down type parabolas. And if it's like a negative x squared, then it'll be downstairs, But we're also going to encounter now, getting away from the idea of functions, just dealing with geometric relations, if you will, just kind of algebraically defined relations. We would say if I had x equals y squared, now the y part is squared, that's when the tables will turn. And we got a left and right type parabola going out to the right-hand side. Or if we want to go negative on it, we can go into the negative with the left, of course. Anyway, so watch out for that. If it's the x squared, if the x part is squared, then we're talking about an up and down parabola. Of course, watching for negatives, that'll flip it. And if it's the y part that's squared, it's a right-hand parabola, a sideways parabola, that can also get flipped with a negative to the left. Anyway, keep that stuff in mind. That's all I wanted you to know. Wanted to let you guys know about a little bit of geometry involved in this stuff.